So in case you noticed, which I know there's hardly anybody watching the videos regularly, and so probably didn't, but I did not work on my tractor over the weekend like I've been trying to get in the habit of doing. And there's some reasons, primarily it's because I was out of town, and there you go. There's the reason. But I thought I did do some work, but it was inside. It was on the computer, and I want to show you what I did. So I'm back out here at the shop. This is the 430 tractor, and obviously I'm going to tear into this side's brakes soon. I've got the seals, no other parts other than the seals. Just clean everything up and the seals. I'm also, in spite of some comments that I've heard recently, I'm going to try to get this thing to actually do something, because it doesn't do anything. But that's not what I did. Down here, there is a rubber boot. That rubber boot is not available for purchase. And as I'm standing here making this video, I'm realizing that what I have done in my office is not going to work. So we'll have to rework it, which is good because I'll do a video while I'm reworking it. But basically, I can't find that little rubber boot. And it's really annoying because it's just a stinking simple rubber boot. And a lot of times what I'm finding on the web is boots that have a outside slide on like orifice, like it slides over something and then has a retainer that keeps it in place, whereas this one just kind of slides into a hole and it has rubber on both sides of that hole, and that's what keeps it in place. It's really short, a lot shorter than I thought. And what I didn't realize, which I just now realized, was that the plate, the place where I stand my foot stand, the floorboard, I guess, is really gonna bump into the way I did my version. So I might have to amend what I did. Don't think it's gonna be a huge problem. But anyway, I have a 3D printer in my house, and I'd like to show you guys how I design and then ultimately print stuff. And I'm not a CAD designer, so, follow me at your own peril, but there are some really cool free tools for people like us so that we don't have to be CAD engineers. And it's not AI. I'll use some AI and I'll show you when, but it's kind of cool, I think. So I'm going to go inside and we'll go into the office and I'll show you what I did. Here we are again looking at this. I'm going to just call it an orifice. It's a hole, but it has some things that we need to pay attention to, like its diameter, how far across is the circle, and then how thick is the metal. Turns out it's a couple of millimeters thick. I'm going to use millimeters because it makes it easier in design. Who knew? When you multiply things by 10, it's just easier. So I think it's like 18 millimeters across and 6 or 7 millimeters thick. And what I'm going to show you is this is what I came up with, because it's very simple. I tried a more complicated design with a relief, like the boot is itself, but this is what I came up with, and I made it out of a 3D print material called TPU, which is like rubber. And obviously now that I've looked a little bit closer, this is going to bump into the floorboard, so I have to make some adjustments, but I'm going to show you how I designed this by designing a new one that hopefully will be better than this one. So there is absolutely nothing special about my 3D printer. It is an Ender, I think it's an Ender 2 or something like that, Ender Pro, and I've had it for a good number of years. The one thing I have found that has made me very happy is that I'm using a Raspberry Pi to do the print server for me so that I can send prints to it. I don't have to use a USB device. That's kind of the only setting on here that that I'm not ready to talk about, but That's how I have mine set up. All right, so I've logged into this website called Tinkercad, and I think it's fantastic. It allows me, someone who doesn't have any experience with CAD, to build shapes and just try things. This is the current version, and I think I'm gonna tinker on this one since I have some settings saved. So let me see if I can, boy, how do I do this? I want to start with this base part here, lose the cone, but I want to show you how I made the cone. So let me take some notes real quick. So let's see if we can speed up this. So I'm going to ungroup all of this, which is only two big parts. I'm going to move the cone over there, and then I'm going to ungroup this guy again. And then that gives me my inside diameter. So let's go on the top. So if I look at this column, it is 28 millimeters. So I'm just going to write that down on a piece of paper because I don't take notes. So 28 millimeters is our inside diameter. Okay, cool. I'm going to move this out of the way. And you can kind of start to see how I did this. I'm going to ungroup this again. And now this guy is interesting. It's 36 millimeters. Okay, 36 millimeters is my outside diameter. So I'm going to move him out of the way. And then this is kind of the magic sauce. This is they call it a torus. And I need a lot of details about it. So it has a radius, so the torus, r equals 16, tube is 3. I don't know what these mean. Sides and steps. I do know what that means. We don't have to write those down. But we are talking about a 45 by a 45. And I think I'm going to call that the outside diameter. And then I think we need to know how tall it is, and that's 7. So 7 tall. Oh, we should probably know how tall this guy is too. How tall are you? 12. 36 by 12. Okay, so this was me just collecting. Let's undo all of those things. Copy, duplicate and repeat. Oh, I'll bet you that's undo right there. Yeah. So let's go back to the way that was when we came here. Good. And now we'll close out of it. So we're going to create. So this is where the tutorial is actually beginning. I always like to use a ruler in here. So I'm going to drag a ruler here. Just gonna, oh, look how beautiful that was. It wasn't exactly centered. Doesn't really matter. And we're going to start off by building our base, which is the part that communicates with the tractor itself. So basically, those things you saw me taking notes on, we are going to, we're going to translate into this guy. No, that's got to be right. Yeah, 36 there, okay, and then we wanted this to be 12. So try to think of this guy, and then we're gonna, I like to deal with things at the midpoint, so I like to center my whole thing over this, and it makes it easier when you do just some simple math to get things to talk to each other. But that's that, it's a cylinder. And try to think of this as, if we just 3D printed this, this big plug would not even fit into the hole because it's too big around. So, okay. Now we're going to grab this torus object and we're going to drag it over here. And before I change the outside shape sizes, because we know those, I'm going to change these inner sizes inside this configuration bin. So 16 there, 3 there, and now I'm going to come change these. These were going to be 45. Now what did I do? Let's undo that. So that's going to be 45, and that's going to be 45. And then tall, I believe, was 7. And that gives us this cool blue, it's like a bracelet, really, is what it reminds me of. And we're going to move it right next to our existing guy. So 0 there, 0 there. And now we're getting close. There's only one problem. They're not in the right relation to each other. The torus thing needs to be higher up. And I prefer, if I'm trying to center things on each other, to just move them both to the midpoint. So I'm on the side view for a reason. It's so that when I grab it, this is how tall it is, this is how far away it is from the center. And by changing both of those to 0, yes, we've moved it so that part of it's on the bottom of the plane, but that doesn't matter. They're going to be happy where they are. So the only thing we have left to do is we need this torus to be a hole. So we click that button there, and now it removes from the orange guy. Okay? All we have left to do now is grab a whole cylinder, bring it over here, and if we remember, we had a 28 millimeter by 28 millimeter. I don't think it matters how tall it is, and we want it to be 0 there, 0 there, and we may as well 0 this out as well. It's going to shoot out from both sides, but that doesn't matter. So all that is left to do is to grab all of the items and group them. And what that does is it combines all of the holes and the solids and makes us a nice shape. So that was quick. I know it's because I stole some settings from the other one, but we're starting from scratch. I wanted us to do this together, so there it is. So okay, that's the first part. Now on my first design, I had just a cone, and that's all I had done. And I don't think that's going to work. What I actually want on this top facing side is maybe a cone will work. It just needs to be very dramatic in its triangle. So thankfully they've got cones, and we're just going to drag a cone over, and I think we want it to be 2 millimeters thick, which means it needs to be 4 millimeters bigger than the hollow hole that we had put in here, which was 28 millimeters. So at the bottom of this triangle or cylinder, it needs to be 32, is that right? Yeah, that gives us 2 millimeters on each side. And then we know how tall this guy is, so let's sink him so he's below the plane now. So, you know, when we slide these two together, they will touch. So we've got this cone, and I gotta say, that's actually already a pretty decent cone. I kind of like it. The only problem is it's solid. So let's copy it. And all we're gonna do is make this copy of it smaller. And we're gonna make it 28 by 28. And then we're gonna make it a hole. And it's the same height. So should we make it less tall? I guess we ought to. Yeah, we better make it less tall as well. So 16. So we want both of those guys to be at the same height. So can we close you for just a second? So this guy's 16 tall. That means he's 18. So we need to bring this down. That was the wrong one. You know what? Let's put both of these on just on top. So 0 and 0 and then 0, 0. Now it's inside. Maybe that wasn't such a good idea. Uh-oh. Now we're in trouble. Let's just move that one out of the way for a second. Oh man, I am making all kinds of mistakes here. 28. There it is, 8. Does that put us straight? Yeah, that puts us right on the bottom. All right, let's, just for fun, let's move that guy over here so he's not in the way. So now you are at 0, 0, and you're against the floor. And now this guy, 0, 0, and you're against the floor. And now we'll union those. Something doesn't look right. You guys seeing that? 0, 0, 28, 28, 32, 32, somewhere. Oh, there it is. 0. Okay, so now we have our hole and we have our cone. Let's union those guys together. So now we have kind of an empty cylinder. So this is good. I like this. Let's move this guy back underneath it. 0, 0. I'm sure you can do all of the commands I've been doing. They can be done with the mouse, but I like using the keyboard. So now we have this component here, and then it has right on top of it a rather small cone relative to the other cone I used before. And let's just give it a name for a second. Break boot version 2. Actually, I think I'm just going to call it version 3 because I think the other one is already version 2. And we're going to leave it as it is for now because I need to go take some notes from the other one again. So we're going to go back to, oh, that was already version 3. What do you know? What I need to know now is how big do we need to make the hole that is right there. So I'm going to ununion again, and then I'm going to ununion again. And this guy here and this guy, do you see how I added a hollow cylinder here? That just kind of made the end of the boot a little bit stronger. So I want to know the diameter of the opening. And it is 12 millimeter. So that's good to know. Okay, we can go back to the other one now. And I'm satisfied with grouping these because they, as you've seen, they can be easily ungrouped. So we're just going to grab another hole. We're going to make it 12 millimeters by 12 millimeters, and I'm going to make it really tall. And I'm going to put it right over top. Do you know, sometimes you have to check this little thing here that says use the midpoint instead of, so back to that. U back to 0. That should put us right in place. Yeah, that makes a nice hole in our 3D design. And then I kind of liked the idea of having a collar around it. So, and this would be kind of easy. Ooh, I didn't know I could do that. That's kind of cool. to make this guy, how thick should I make the collar? 4 millimeters sounds like too much, so let's make it 2 millimeters. And am I regretting that I already merged this guy together? I think I am, and you'll see why in a second. So I'm going to move that guy out of the way for a second. I'm just going to put him inside there. And I'm going to ungroup these. I'm going to move you out of the way. Not that it's necessary, but I just wanted to. I'm going to ungroup those two guys. And I like that better. That way, when I union all of these together, there won't be weird artifacts hanging out. So I set you to 0 and 0, and that will make our entrance hole. And then I want this guy here. First off, I don't want him so tall, so I can just grab by the mouse. That moves it. What's the way to, oh, you grab there, so that makes it 6 millimeters is too much. So let's make a 4 millimeter collar. And what did we say? We wanted 2 millimeters around the side, so that's 12. So this needs to be 16. We're going to move it into the middle. And then we're just going to eyeball where it should be. And that's when we grab this triangle. So let's get a little bit closer. It's going to be hollowed out by this guy here. It fits pretty nice. I mean, I kind of like that shape. And we just eyeballed that, so not too bad. Let's push this down a little bit. I don't think it's necessary, but oops, I wanted front. Just drag him down. Yeah, that's all that mattered. Okay, group all of these together, and what we should now have is this little angle with a collar. Yeah, I like it, and it should be right at the bottom. So when we move this guy back to the middle, the center, that should now be a nicely shaped boot with a relatively short and abrupt cone. So now I'm just going to download that, and we'll move over to the next phase. Okay, I'm sure there are plenty of apps you can use. I like Slicer. It's free. I'm kind of a big free guy, and it's pretty easy to use. So let me add our file to it real quick. Okay, it's been added. Let's zoom out a little bit, and there it is. Now I've got to turn on my 3D printer, and I'll show you guys some video of this printing. I'm going to print a model of it in regular cheap filament so that I can just be sure I'm happy with the things. And in order to do that, I'm going to switch over my settings to my filament settings. And I'll talk about that in a minute. So I want my prototype fast settings, and I want my, where's my fast one? Try that one. I can't remember what that one does. And this one just says it's working. Okay, excellent. So give me a second. I got to start up the 3D printer. Last little note here before this actually starts printing. I like to store my print head kind of high like this so that the print material, the PLA, doesn't have such a long distance from the reel down to the print head. When I used to keep it down here, I would constantly have broken print material. So who knows, maybe I'll still have broken print material as the head drops when it's ready. But it's just something I do to kind of help keep things from breaking. And that's done by simply, once everything is configured, hitting send to printer. And now we just make sure that that worked. And it looks like I tried to do it before the server was ready, so it's timing out. So let me get everything started up and then we'll send it. So the service I'm using that runs on a Raspberry Pi is called Octoprint, and I find it pretty darn nifty. It's free, again, so all you're buying is a Raspberry Pi, and then I just connect it with a USB cable, and I have a print server. It's fantastic. Been using it. Yes, I'm aware that that's broken. Get to that later. Let's try this again. Send to printer. And boom, just like that. I like how I've got a little chart that tells me I've started, and my printer is warming up. So I do not have a screen, or sorry, I don't have a capture device on my printer that's going to show you the time lapse of it printing. Sorry. Feel like that's excessive and I don't need it. So I'll be back and I'll show you the prototype. So there it is. Let's tear it off of there. Like I said, I printed it with some settings that are like really fast. It's a little bit messy, some strings inside, but let's see if we're in the right ballpark. Yeah, I think we are. Probably smash it in there if I really tried. But I like it. Let's make it out of the rubber. And here's where the story gets semi-interesting. Okay, all I gotta do is pick my TPU. I think it's the boot one. Boy, I hope that's the right one. I guess I've got a couple. I didn't really no support version 2. That sounds right. And that's it. I don't want support material. Make sure to turn that off. So this is pretty simple. I go into the settings. I heat the end. That gets this part here nice and hot. So we need to give that a second because it had cooled down quickly. Little fans on here. So let me quickly tell you how I got my TPU settings. I exported the configuration file from the program slicer. I uploaded that to ChatGPT and I said, these are my current slicer settings and they work whatever, okay for PLA. I'd like you to change them to work with this TPU stuff. And we went back and forth, I think 3 times, where I would print something, I actually sent it a picture, it would say, okay, something we can change is this. I would upload it again, and I'm very pleased with the end result. There is only one problem, and you'll see it when I print this, but on the front half right here, when it's doing this edge right here, this TPU right here, it's too hot, too long, and it droops. And so you lose a couple of strings from here that fall off the edge. We might have a problem with how sharp that angle is going to be now. But let's just try it because you never know. So, okay, the end is hot. And so I think it's the easiest to pinch this on the feeding engine. our motor and just pull it out like that. Works every time. Okay, some other tips. I should be keeping my filament in some kind of desiccant or something that ensures that it doesn't absorb any of the humidity from the air around it. Yeah, I don't do that. So there's a chance that we're going to get some spurts and stuff this time when printing it. So could be a problem. Hopefully not. So I manually feed it down until I get some resistance. Then I go in here and I move the axis for the extruder. That's how I've found this to be done most easily. And then if I move this up a little bit, I like to do that. So we'll just start pushing until it feeds out. Hopefully the temperature is warm enough for the TPU. It's currently pushing some of the other stuff. Let's see if I can get a better view on that. Still kind of red. And we'll just keep pushing until we get a nice solid line of the TPU, which is very black. Until it's starting to darken. Okay, that's probably adequate there. So we'll go back to the home page. Call this thing ready for our next print. We're going to overwrite and start the print. So our new print has started, and oh, that's interesting. There's no time left. It's probably going to take about an hour because it should be moving a lot slower now. Okay, so the print has started, but I can hear the printer running and I can tell already it's too fast. So another reason that I like Octoprint is right here I can hit cancel. And I can hear the machine. It's gonna stop. There, it stopped. So let me restart this. All right, cleared the piece off the bed. And it was TPU boot, no support version 2. That's the slower settings. And I did that by going to the print settings and seeing the speed. And I just changed my configuration files until I found this one, like 18. That's slow. So hopefully this one will do a little bit better than the last one. And those temperatures have to come back up before it'll start. It's too bad it doesn't do both temperatures at the same time. Waits for the bed, then it heats the end. But anyway, we'll have all of this on, I guess I can do a time lapse on my phone. And so we'll see the ending piece here in a few minutes. All right, that took 1 hour and 45 minutes. And there it is. Now, like I said, on the front side, it gets that kind of goofy where the lines come off. But we trim those off and the rest of it works pretty darn good. Alrighty, the final test. Let's see if it fits. Oops. Push it in there, it's deformed. There it goes. Yeah, that is probably adequate. So I'll print the other one offline. All right, it's the next morning. Yes, I let this thing print overnight. I can't tell you how many times I've done that. It's been okay, but I'll have to trim off those goofy spots, and this thing will be fine. So there you go. There's a video on how to make your own parts. I'd like to do some machining on this channel, but for now I just needed some rubber boots, and that'll do. Thank you again for watching, and I hope this helps. So I hope it's obvious, but this is a brand new channel, and I have just started documenting my hobbies. Please subscribe. I do respond to comments. You guys are great, and thank you so much.